and we got the instructor's room. And then we got all the dimensions that are given to us. If you look at the top, there it says the ceiling height is 2.8 meters, and then your gable is 1 meter, right? Your gable, I'll explain that just now for those of you that are not familiar. But gable, basically your roof pitch. It's 1 meter from at the apex. Then we got dimensions. The overall dimension of this, the length of it is 12.19 meters. And you'll notice that the width is 8.46 meters. Then we got openings like a double door here, which is 2 by 2.4 meters. And then we got a window here, which is 2 by 1.8 meters, 2 meter by 1.8 meter. We got another opening here, which is 1 meter by 1.6 meters. We got, oh, sorry. My apologies. These are, okay, the double door, these dimensions that I just called out is for something else. It's for the lintels, and I'll come back to it. But basically, the opening, the opening here is 1 meter by 2.1 meter high. The opening is 1 meter by 2.1 meter high for that printing room. Then the instructor's window is 2 meters wide by 0.9 meters high. The doors are 0.9 by 2.1. Each door is 0.9 meter by 2.1. So here you're going to get 0.9, 0.9. That's a double door. If you look at the way the opening, that arc, the arc normally represents how the door opens. So here you got 2 doors opening from the middle. And then obviously this door here is going to be a standard door, which is 0.9 by 2.1 meters. Then the window, your window here is 1.2. That's the window there. The window is 1.2 meters by 0.9 meters high. And then they tell you that a standard brick is 220 length by 110 width by 75 high. That is a standard brick, just to help you out. Okay, don't worry about the dimensions that we typed in. I'll tell you just now when we get to the actual calculations. Right. I'm now going to bring up the calculations, just bearing in mind the dimensions and so on. I'm going to bring up the calculation for us to extract quantities. Right. And let's look at right. You can all see that what we had to extract. First of all, they want to know what is the quantity of mesh that we're going to require. Now, mesh 193 is a mesh that you normally put before you pour your concrete for your floor. Right, the mesh goes, then you put your plastic, and then you pour the concrete. Now, the mesh 193 got a nominal opening of 100 millimeters by 100 millimeters. So that's the reference of the mesh. Now, this is going to be a rough foundation. It's a small building. Normally, otherwise, we'll put proper reinforcing, but here we're just going to run a mesh on the floor. Now, if you look at the mesh, they say the area is going to be the unit of measure is going to be in square meters. So you want to find out the area of mesh that you require. And I've just worked it out there quickly. That's the length of the building, which is 12.19, by the width of the building, which is 8.46. And the quantity that I require here is 103.13. We're not going to do the rate and the amount now. We're just going to extract the quantities. So there we go, 103.13. And I just showed it on there. Then that was fairly straightforward. Now, basically, what we had to do there for the mesh was just basic your length by your width of the building. Then they wanted to know the face brick, the amount of face brick. Now, if the building, the outer skin is going to be face brick, and the inner skin of a double wall is going to be normal cement brick. So we only put face brick on the outside. We don't put face brick on the inside because we're going to, unless exceptional cases, if you want to leave it like that. But in this case, because we're going to plaster and paint, we'll put cement bricks and we'll plaster and paint. You don't want to put expensive brick on the inside and then close it up with plaster. So face brick on the perimeter, and we need to calculate how many face bricks. Now, there's the calculation here for the face brick. I'm going to just show you. Right. Now, you'll notice that they told you that the height, ceiling height is 2.8 meters. So for the one wall, I'm talking about the wall, the length of the computer room. Remember, we said it was 12.1 meters long. So the one wall is going to give us 12.19 by 2.8 meters high. Right, and I'm going to have two of those walls because I'll have one on the south elevation and one on the north elevation, right, of the building. So just picture that out. Now, basically what I'm saying, if you look at this diagram here, there's one of that wall there and there's another wall there, right? Those are the two walls that I got. So it's 12.19 by 2.8i, and I multiplied it by 2 for the, I said, the north and the south elevation walls. And you'll notice that comes to 68.264 square meters. Right, for now, I'm just going to work out the square meterage because anyone knows how many bricks make a square meter? Anyone? How many bricks makes a square meter? How many bricks in a square meter of wall? Now, we obviously look at single skin, double skin, we'll just multiply it by 2. In a single skin, anyone knows how many bricks make a square meter? Okay, if you calculate it exactly, it normally comes to about 52, but for wastage and so on, we allow 55. We'll allow 55 bricks for every square meter of wall that we're going to build. So I've got 68.24. So if I had to work on how many bricks, multiplied by 55 would have given me how many I need for these two walls here. But let's leave it. We'll work on all the area and then we'll just multiply by 55 at the end. Then if you look at now these walls here, which is the shorter wall, in other words, the width was 8.46. Same story, I'm going to get 8.46 by 2.8i times 2 of those, right? 8.46 times 2.8 meters I times 2 of those walls, which will be my west and my east elevation. And that comes to 47.376. And now I need to also add for that gable. Now remember, the gable is always on the shorter side most of the time. You can get on the longer side, but unless otherwise specified. The gable, now if you look at the pitch of the roof, it's going to pitch slab. So I need to calculate the brickwork that I need both for the west and the east elevation there. And that's simple. The apex is going to be normal half base times height. That will give me the area, and I multiply by 2 because there's 2 of those, the west and the east elevation. So 0.5 times your 8.46. That's the width of so half base, 0.5 times the base is 8.46. And they told you the height. Remember, they told you the gable height is 1 meter. So that's how I got 0.5 by 8.46 times 1 meter. That will give me the area for there. And then for the other elevation, I said west and east, I multiply by 2. And you'll notice that will come to exactly 8.46 square meters. So I add the 2, it gives me 55.836. And then I got 68.264 for the other two walls. Right. Then I could have went and very quickly put the number of bricks here. If I wanted to, I just have to multiply add that and that times 55. Right. But then also I want to take away areas for the windows and the doors before I do anything else. Right. I'm going to take away areas for the windows and the doors. Now my total face brick area, if I add the 268.264 plus 55.836, you'll notice I'll get 124.1. Right. That's for just the walls and the gables, 124.1. I'm going to take away for my openings. My door, first of all, remember I got a double swinging door at the entrance, a double swinging door, which I said was 0.9 meters wide by 2.1 meter high times 2, because there's 2 of those doors there. That's how I get the doors there. There's 2 of those doors. And remember, we're only working with the external walls. We're not doing anything on the internal walls because face brick is only going to be on the external walls. Then I'm going to take away for the one window. The window was 1.2 by 0.9i. And you'll notice that my total area now is 119.24 square meters. And I'm going to go just now back to the drawing just to explain exactly what I've done. And so 119.24 times 55 bricks per square meter, that comes to 6559. Exactly 6559 bricks. Right. That comes to exactly 6,559 bricks. Class, if you just allow me 1 second now, I'm going to go back to the drawing just to explain what I've done. very quickly. Right, you can all see the drawing, right, class? Can you all see the drawing? So basically, you'll notice what I've done for initially your mesh, straightforward. I just took the length of the building and I multiplied it by the width to give me an area of where the mesh goes into the floor. So that was 12.19 by 8.46, and I got the area of the mesh that I require. Now for the bricks. Now, if you look at this, these are all your external walls. These are your external walls. There's the internal wall. The internal walls is a single skin, which we refer to as half brick. The external walls are all double skin. And the double skin is got face brick on the outside, and it's going to have cement bricks on the inside. So I worked out all the brickwork from the outside, including the gable that you'll get here for the roof. And I took away for the door, the opening for the two doors, double door there, and I took away for the opening for the window there, right? And that came to 6,559, roughly 6,559 bricks for my face bricks, right? Any questions, class, regarding that so far? Any questions? Right. Now we're going to work out for the internal bricks, which is cement bricks. Now I can just use the same value for the external walls. There's no need for me to go and adjust, because although it'll be slightly less, couple of bricks, but no need, because we're already allowing for wastage and so on. So I'll use the same value as the face bricks for the external, and then all I have to do is add the internal walls, those partition walls there, and take away my openings, which will be one opening here as a door. I'm going to have an opening for the instructor's room and an opening as an entrance as well. Yeah, there's no door, but you'll notice that because it's got a broken line there, it's just an entrance, just like an access into the print room, but there's no door as such. Right. So I'm going to now go and work out for these walls, because we can add the 6559 for the external walls. Right. Let's go back. Right. So far we basically did item number. Okay, sorry. I did item number 1, item number 2, which is your face brick. We got 6559. Then they wanted to know the damp proof membrane, DPM, 250 micron. That's the thickness of the membrane that normally goes on the floor to prevent any capillary action of water. You don't want water seeping into your building, so we put a DPM. Now the DPM will be exactly the same as the mesh, because it actually sits underneath the mesh, you know that, right? And then you pour your concrete once you laid your mesh over the DPM, right? So exactly, no need for me to go and calculate anything. It's exactly the same. It'll be the same area. Then we said item number 4, cement brick to perimeter inner plus internal walls, right? The cement brick to the perimeter inner wall, in other words, the external wall, the inner, plus all internal walls. And I'm going to show you how we're going to get that now. Right. As we know, we're going to add that 6559. It's the same. We said we take the same number from the external walls, plus the internal walls, the one internal wall that ran between the computer room, there's the workstations, and your filing and your instructor's room is 8.46 meters long, because it's the width of the building, times, you'll notice that the length, if you worked out sorry, what am I saying? It's 8.46 meters for that. And then there was one wall that separated the instructor's room from the filing room. That was 2.615 meters. So we added those two walls and we multiply by 2.8, because remember that the internal walls will only run to the ceiling height. They don't run up to the gable, right? They run to the ceiling. So that will give me the area of those walls. Then I have to take away for the openings. The one opening was the normal access into the filing room, which was a normal 0.9 by 2.1. Sorry, that was for the door, 0.9 by 2.1, the door going into the instructor's room. Then the normal instructor's opening for him with his viewing glass there was 2 meters wide by 0.9 meters high. I took away for that. And then finally, we got the access that going into the filing room, we said was 1 meter by 2.1 meter wide. Right. So those are the three openings that I need to take away. And if I look at it, I get the 6559 square meters. Sorry, not square meters, bricks, plus square meterage. Remember, this is 31.01 square meters if I work on that, minus all those square meterage, 1.89 for the first door, 1.8 for the instructor's window, and 2.1 meter for the access into the filing cabinet. You'll notice that will give me 6559 plus the 31 times 55, because 55 bricks per square meter, minus, if I work out that comes to 5.79 square meters times another 55 bricks that I'm going to take away from that. So it's 6559 plus 1708 minus 318 bricks for all my openings comes to 7,949. So I need 7,949 cement bricks as opposed to the 6,559 of my face bricks. Okay, then I'm going to do the last one now with you quickly. Is if you look at the next item, they say your brick force. I'm going to do brick force. You have to work the rest of it. You're going to work the lintels out for me. I put the measurements and so on there, and I'm going to tell you basically what happens to lintels when you work on the lintels. I put them also on the drawing. Is that wherever you got an opening, you will have to add extra, because remember, lintels actually sit on the adjacent walls. Lintels are there for opening. For example, when you put a door, you know the door height is 2.1 meters. Above that, you need to put a lintel, which is like a reinforced slab. It's actually a reinforced slab, and then you can carry on with your brickwork. You can't carry on with the brickwork other than that, unless you're going to put formwork and structures and so on, which is, it's much easier just to put a lintel. Okay, right, now I'm gonna very quickly go back to the diagram on that one quickly, just to explain what we've got there, and then you can see how we got all the values there. Let me bring up the diagram quickly. Let's look at the drawing quickly. Right, you'll notice now for the lintels, yeah, because it's a what we can refer to as a double skin wall. A lintel is the width of a single skin. Lintel is a width of like this internal wall. So I'm going to need two lintels there, which will sit, they'll sit butt to butt, in other words, next to each other. So in this instance here, because remember I told you that this window here is 1.2 meters, isn't that so? I told you the window is 1.2 meters by 0.9 meters high. Now I need 300 on either side so that I get enough. In other words, you need at least one brick, right? You need one brick length so that it gives you support. In other words, you place your lintel, you place it on as though it's occupying one brick there. Now, a brick is normally about 230. We just add 300 to be on the safe side. Just add 300 to each lintel. So that's how I get 2 by. Normally, I would have needed a 1.2 meter lintel, but because 300 on that side, 300 on that side, that's why I got 2 by 1.8. You all understand that, class? I'm going to need two lintels 1.8 meter long because I need a 300 overlap on either side. Similarly, if you look at here, I'm going to also need two lintels, but the opening of the door is actually 0.9, 0.9. That's 1.8 meter. You agree? Then I need 300 on that side, 300 on this side, which gives me the 2.4. That's why I need 2 by 2.4 meter lintels there. Class, quickly, can I have your feedback? Are you all clear with that? Anyone? Does it make sense? Yes, no, class? Yes.
Can we go over the lentils one more time?
Okay, let's go through it. Right. if you look at this, first of all, I said this window here is 1.2 meters wide. That's the opening. The opening will be 1.2 meters. So when I put a lintel, I need to overlap it one brick on either side. So that's why I said 230. We just add 300 to it. So 1.2 meters plus 300 plus 300. That's how I get a 1.8 meter lintel. So I'm going to need two of those because they sit butt to butt. 2 by 1.8 meters for there. This opening here is 0.9, 0.9, which gives me a 1.8 meter opening. Plus 300, so gives me 2.4 meters. I'm going to need 2 by 2.4 there. You understand? Is that okay now?
Yes, sir. Yes. Thank you.
Right, perfect. Right, similarly here, if you look at this door opening here is 1 meter. So 1 meter plus 300, I'm going to need a 1.6. Same here, this is 2 meter opening. 2 meter plus the 300 gives me 2.6. But because the internal walls only need one off. You see, I don't have to place them side by side. And that door there was 0.9 plus 300 gave me 1.5 meter. Those are all the lintels that I'm going to need, right? Those are the lintels there. And if you look at it, I'm going to bring up the calculation again quickly. I just wanted to confirm quickly is what's the name? Okay, I can check it out on the register just to check. I want to check if Kumalo is here. Kumalo is in the class. Is S Kumalo in class? Msomi, eh? Is Kumalo in class? Msomi? Okay. Right. Now we're looking at, there we go. That's why I got that. I said I needed 2 by 2.4 meters that goes over the door. I needed 2 by 1.8 meters that go over the window. Then I needed 1 by 1.5 meter that goes over the opening. And then I needed another 1 by 2.6 that goes over the instructor's opening. And then I needed another 1 by, sorry, that should have been just 1 by 1.6 meters that went over the door again, because the door the opening was 1 meter, so it's 0.6. What's here? 1 by plus 1 by 2.6 plus 1 by 1.6. It's about, don't need that. Okay. Same thing. It would have came, the answer would have values come the same, but I just need plus 1 by 1.6 there. Okay. Right. Then the next one I said 150 millimeter wide brick reinforcing. Now, brick reinforcing is you have to put it just to make sure that it holds or bonds your brickwork properly. And for the external wall, you use a 150 because it's a double skin wall, and every 3 courses you put that there. Then for the internal wall, it's just a single course. We use 75 millimeter thick, right? And internal is every 5 courses, right? So you're going to have to calculate now. That's what I'm leaving you. That's your tutorial. I've given you the answers here. I've given you the answer on there. I'm going to leave that answer. Oh, no, maybe I should actually take it out. I know it's on there, but doesn't make a difference. But I'm not going to show you how I came up with the calculation. You're going to work through that. You're going to look at the building. You have to take every 3 courses. You have to work out how many courses, first of all, you're going to get. You take every 3 courses, and you're going to put the brick force or the brick reinforcing along the external wall. For your internal partition walls, every 5 courses, and it's in meters. I'll leave the value there because you obviously already seen that there, but I want you to go through that as a tutorial, and let's see how you come up. You're going to show me, you're going to make sure that you worked out everything, and then we'll take it from there. Any questions, class? Any questions?
So what do you mean by every 3 courses and every 5 courses?
No, what I mean is when you're laying your brick now, you start with your brickwork, right at the bottom from the floor. When you're starting from where you cast your floor, normally what happens is that you put you normally put a membrane as well right at the bottom. You don't want water to seep through the floor, and then you put a course of this brick force. You all seen brick force, like it looks like a ladder in a roll, isn't that? So it comes in a roll. They lay that, and then you put your mortar over that, and you put your brickwork. So what we're saying for the external walls, every 3 courses. So you'll put the reinforcing, which is the brick force. You'll put 1 course of brickwork, 2nd course of brickwork, 3rd course of brickwork. You'll put another course of brick force, and then that's what I mean. Every 3 courses of brickwork. Internal walls, you only need them every 5 courses. So you'll go 1, 2, 3, 4, 5 courses of brickwork, and then you put another a brick force. You use a roll and you run it. I'm sure you've all seen houses being built. That's the little reinforced wire. Okay, does that explain it?
Yes, sir. Thank you.
Right. Okay, so basically that's all. I want you to calculate those 2 for me, because remember, it's not just a simple calculation. You have to minus for all your openings, depending on how many courses of brickwork you got in the opening. You have to take away for that. You also have to include your brick force in your gable, and that can get a little bit tricky, right? So I want you to do the calculation, and then yeah, and that will be for your next tutorial. I'll post this on Moodle, what the calculations that I've done, and I'll take away the ones that I want you to do for now, and then you can work through those. Okay, thank you very much, class. Any more questions? Any further questions? Okay, don't forget as well that the test date is the 23rd of March. As it stands currently, seems like it's going to be online. If there's any change, I will let you know. Right, starts at 8 o'clock. It's during this lecture. Okay, and it will obviously cover everything that we covered till next week, eh? Okay, class, don't forget that, eh? And I'll let you know next week what's going to be.
That's the 23rd of March.
Yeah, that's test 1 on the 23rd of March. That's Wednesday, the 23rd of March. I think Monday is a holiday, the Tuesday, and then the Wednesday you're writing at 8 o'clock, eh? Okay. Thank you. And then test 2 is 20th of April, but we got some time for that. Okay, class. Thank you very much. Is there any questions before we class? I presume there's no questions. Then let's leave it at that. And please, yeah, just go through that tutorial. Thank you very much. Take care. Bye.